What causes welds to fail from shear force? Imagine a bridge or a building that suddenly gives way not because of a big crack but because a tiny weld couldn't hold up under pressure. That's shear failure in action. When you think about welds, they're like the glue holding metal pieces together. But if the load on that glue gets too heavy or the weld isn't strong enough, it can slide apart. Shear force acts parallel to the weld surface, trying to make one part slide past the other. If the shear stress in the weld or the base metal exceeds what it can handle, failure happens. The strength of a weld in shear depends on how big the weld is, its shape, and the area through which the force is transmitted. For fillet welds, the critical part is the throat, which is about 0.7 times the length of the weld's triangle side. If the shear stress on this throat gets too high, the weld can rupture. One common cause is when the weld is too small for the load. If the weld size doesn't match the force it needs to resist, the shear stress concentrates and causes failure. Sometimes, the weld is stronger than the metal it joins. In that case, the base metal itself can shear off before the weld does. This happens if the base metal's shear strength is lower or if the shear area in the base metal is smaller. The direction of the load also matters. When the force runs along the weld, failure occurs right at the weld interface. But if the load is at an angle, around 22.5 degrees, the stress distribution becomes more complex, and failure can happen at an angle. Stress concentrations are another factor. The edges of the weld, called toes, and the heat-affected zones can develop tiny cracks or microstructural changes. These act like stress risers, making it easier for cracks to start and grow under shear load. Imperfections inside the weld, like porosity or inclusions, weaken the joint further. Repeated shear forces, like in machinery or bridges, can cause fatigue. Over time, tiny cracks form and grow, eventually leading to failure. If the load isn't purely shear but also involves bending or twisting, the stresses can become uneven, increasing the chance of shear failure at specific spots. To prevent this, engineers make sure the weld size is enough for the expected load. They also select materials with similar or higher shear strength and ensure proper welding techniques to avoid defects. Proper design, quality control, and understanding of how loads are applied help keep welds from failing unexpectedly. Knowing these failure mechanisms helps us understand why sometimes welds give out and how to make them stronger. It's all about balancing the forces, materials, and design to keep everything safe and reliable.